Hello students, in this video we're going to do differentiation. Differentiation is a very wide topic. There are many rules that we need to learn in this chapter, such as the chain rule, the power rule, the constant rule, the sum and the difference rule, product rule, quotient rule, etc. So in this part A of differentiation, we're just going to do some of the basic rules that you need to have before we can go on to learning the product quotient rule. Differentiation was introduced, or rather was developed, independently by two great mathematicians. One is Isaac Newton, and the second one, I would not embarrass myself by trying to pronounce the name, but you can see it on the screen. Both of them developed calculus, the fundamental concept in calculus in the late 17th century. So both two mathematicians introduced it as part of their respective frameworks for calculus, although their notations and approaches differ. Isaac Newton viewed differentiation through the lens of motions and change, whereas for the other mathematician, he developed a more systematic and symbolic notation for differentiation, such as dy dx, which is still in use today, which we will be learning in the next few slides. However, the modern historians generally agree that both men contributed significantly and independently to the development of differentiation and calculus as a whole. So therefore, we should try to do our best to study this chapter diligently. Differentiation is widely used in real life to analyze and predict changes across various fields. In computer science, it's essential for machine learning, image processing, and graphics rendering. In the medicine and biology, it models drug effects, population growth, and heart rate changes. In economics, it aids in cost optimization, profit maximization, and understanding supply and demand elasticity. In physics and engineering, it helps calculate velocity, acceleration, and optimize designs. Architects and engineers use it for stress analysis and design optimization, while everyday applications include speed measurement, weather prediction, and financial risk analysis. Right, so differentiation is actually a mathematical technique used to find the gradient or slope of a function at any given point. So the gradient represents the rate of change of the function with respect to its independent variable. So what does it mean? Supposing if you are given a function y equals to x squared plus 3x plus 5, if you were to sketch this curve, this is how it looks like. Right, you can use completing the square method to find this lowest point here, which will allow you to find the lowest point, the minimum point as negative 3 over 2, comma 11 over 4. So what it's saying is that if I want to find the gradient at this point x equals to 2, say this point here, which is x equals to 2, right, I will draw a tangent line, right? So if I'm able to find the if I'm able to differentiate y respect to x to get dy over dx, which basically this is called the gradient function, right? It's called the gradient functions of the functions, right? And then when I substitute my x equals to 2, I would be able to find the gradient of this tangent line, which is 2 times 2 plus 3 gives you 7. So in other words, the gradient of this tangent line will be 7. Right. So this is how useful it is. Once you know the gradient function, you can just substitute the x coordinate of any point to find, okay, the gradient of that tangent line the particular point that you want to find. So in this chapter, what are the key differentiation rules? We will need to learn how to do the most basic one, that's called the power rule, followed by the constant rule, the constant multiplication rule, the sum and difference rule, product rule, quotient rule, and then the chain rule. So we'll be learning 1, 2, 3, 4, 7 in this video. Right, so in this slide, I should attempt, when I use the word attempt, because I need to confess that I don't quite understand limits too. All right, so let's learn together. We will be learning how to find the derivative, which is the dy dx that we talked about just now, the gradient function, finding it from the first principle using limits. So let's start off by having a curve which has the equation y equals to x squared, having 2 points, P and Q, all right? And this is what we need to do. Finding gradients of PQ is easy. We've already learned it earlier on using rise over run. Okay. So what we are saying is that imagine you are, okay, point P is stationary, point P is not moving, whereas point Q moves. So imagine you're at the point Q and you want to get very close to point P. You want to get very close to point P, but you're not actually point P, just want to get very close to it. So imagine that if you move nearer and nearer and nearer and nearer to point P, then the line becomes the tangent line at point P. So the gradients of this point P, right, it's equivalent to taking limits of the gradient of the line PQ. That means taking limits of this gradient. Right. Sounds cheap, right? Okay. So our job now, all right, is to find the limit of this gradient PQ in the next slide. Okay, so to find this limit, this is how we do, right? So same thing, we start off with a curve where you have equation y equals to x squared, and we have a point Px comma y, but in this case now my point Q is no longer x2 y2, but my point Q is very close to my point P by a certain distance, what we call it delta x for the x coordinate, and for the y coordinate is called delta y. It's a very short, very short distance. That means you are very near. Okay, if you are the point Q, you're very near to point P. Okay, then let's see what happened. So we're going to substitute x plus delta x into your equation y equals to x squared. Right, so you're going to substitute this point into this curve here. That means my y coordinates has become y plus delta y. Originally, your equations of the curve is y equals to x squared, isn't it? Right, so you're going to substitute your y with the y coordinate here, which is y plus delta y. And then your x coordinate is x plus delta x. Right, so we're going to expand this using your algebraic identity. To get x squared plus 2x delta x, and then plus delta x squared. All right. So gradient of PQ, recall how we find gradient of PQ, isn't it? Y2 minus Y1, which is y plus delta y minus y, and then x2 minus x1. This is like our x2. Right. So okay, wait, very confusing, right? Let me erase all this thing. Okay, erase all this. So this is our x2, y2. This is our, okay, this is x2, that is our y2, and this guy is our y1. Wait, wrong. What am I doing? Here. I'm here lah. Point P is here. This is our x1, y1. Okay? Right. So y2 will be y2 minus y1. So that's how we get y plus delta y minus y. And then x2 minus x1. That's how we get x plus delta x minus x. So if you simplify it, you get delta y over delta x. All right, but if you look at what we have above, I'm going to replace my y plus delta y with this, which is actually this guy here. Okay, so I replace it here, right? And then my y is actually my x squared. That explains my x squared here. So what happened to the below will be just delta x, because x minus x give you 0, so you're left with delta x. So that simplifies the top. So x squared minus x squared will be gone, right? This and this will be gone. So you're only left with okay, so how do I end up getting this? So what you are left is 2x delta x plus delta x squared over delta x, right? You split it into two fractions. Okay, so this and this cancel off, and this divide by this. There are two of this, so divide by this. So left only 1. Okay, so that explains what happened. All right. Okay, then what's next? Okay, what is next is, as you get very close, your point Q, as you get very close to point P, right? This one tends to 0. The meaning of tends to 0 means you are not point P. You can never be point P. P and Q are two different points. You just get very close to point P such that it kind of becomes 0, but it's not 0. So the gradients of PQ, so when you tend to become 0 but not 0 means it's negligible, means you are not of a concern anymore, because you're just like not there, right? So the gradient of PQ become 2x, right? So therefore 2x, the gradient of PQ goes to 2x. So the expressions, the derivative, 2x is a derivative, which is a dy dx. It's the gradient function that we talked about just now in the beginning, the example that I gave you. Okay, so which can be used to find the gradient of a curve y equals to x squared at any point. So therefore 2x is called the derivative of y respect to x, or your dy dx, or the gradient function for the curve y equals to x squared. Right, there's some important notations that we have to take note, because the questions can be given in different formats. For example, if you're given a question such that y equals to x squared, right? So the derivative will be dy dx. Your gradient functions will be dy dx. However, instead of giving you y equals to x squared, I'm giving you a function f of x equals to x squared. Then in this case here, the derivative is called f prime of x. Right, and sometimes you can also write it this way. That means you are writing you are differentiating, okay, you're differentiating this function respect to dx. All right, so you have to take notes of different notations. So which notation is more useful? It will depend on the questions, okay, that you've been exposed to, right? Depending on which variations are given in the questions, so you answer accordingly. Right, let's look at these three different rules: the power rule, constant rule, and the constant multiplication rule. So the power rule, it's if you have x to the power n, right? So you're finding the derivative of x to the power n. It's quite technical, meaning you just have to remember the steps. You bring the power n to the front, and then the power minus 1. Constant rule means when you differentiate any constant, basically you're finding gradients of For example, let's say y equals to 2. 2 is a constant, right? Constants are, there's no variable there, there's a constant. So for y equals to 2, we're talking about horizontal line. So the gradient of a horizontal line will be 0. So this is what we learned earlier on in coordinate geometry. Okay, and then if let's say, for example, what does constant multiplication rule means? If you need to find the derivative of, let's say, this variable 3x, so what you do is you just take out the 3 and you are actually finding the derivative of x only. Okay, so this is constant multiplication rule. So let's look at some examples. All right, let's look at A. Okay, so recognize that the power is 50. So step number 1 is to bring 50 to the front. You're right, and then the power minus 1. So 50 minus 1 gives you 49. So that's quite easy, yeah? Then, okay, so in the earlier video, I have one video that actually prepare you before we do this chapter on differentiation, that is to be able to apply the rules of indices. Like for example, this one here, this is a positive power. We must be able to know how to convert it to a negative power. Able to convert it in this format, x to the power of something. You must able to convert it into the format x equals to something, then you can apply the power rule. So 1 over x to the power, then you can convert it to x to the power negative 10. So this will be your power, but you can just bring it to the front. And then minus 10 minus 1 gives you negative 11. Let's look at part 3, C. Okay, you'll be able to cube root of x means x to the power 1/3. All right, so here we will be applying your rule number 3, the constant multiplication rule. We just ignore your half and we just differentiate x to the power 1/3. Okay, so you see that I actually ignore my half and then I just differentiate this guy here. So the power 1/3 bring to the front and then 1/3 minus 1. So half times 1/3 will give you 1 over 6. Okay, so this is how we do it. Right, next one. So x to the power of e. So we bring e to the front, then e minus 1. So this is exact value. All right, non-exact value means you have to evaluate e. So e is actually 2.72. And 2.72 minus 1 is 1.72. All right, so you can leave it in the exact form or leave it as straight significant figure. So, but of course, if the question requires you to leave it exact form, then that should be the answer. But let's look at E. Right, pi x. So pi is a constant because pi is 3.142, blah, 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 blah. So it's a constant, it's an irrational number. So that's why blah, 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 blah. All right, so you leave pi alone and you differentiate x. So x means x to the power 1, right? Right, so we bring the 1 to the front. 1 minus 1. 1 minus 1 gives you 0. X to the power of 0 will gives you 1. Right, so you get pi. So basically, this is quite easy. All right, if you want to find the derivative of y equals to 2x, that will be 2. Derivative of 3x, that will be 3. 4x, that will be 4. Negative 5x, that will be negative 5. Half x, that will be half. So on and so forth. Okay. All right, so let's look at the next question. It's a sum and difference rule. So basically, sum and difference rule means if you're asked to find the derivative of two different functions, okay, two different functions, f of x plus g of x or f of x minus g of x, you can just find the derivative of each one of them separately. Okay, like for example, if I'm asked to find the derivative of 3x squared plus minus 4x, then I can just find the derivative of 3x squared plus minus derivative of 4x. Okay, but there's one common mistake that I need to remind you folks. Right, the common mistake is this. if you were to look at it very carefully, you will see that this one is the derivative of 2/3 x to the power 3 over 2, right? However, this term here is not the derivative of 3 square root x. It's a 3 square root x itself. It's another way of writing 3 square root x, where you actually convert square root x. Square root x is radical form. You convert it to index form x to the power half. And of course, 5 is a derivative of 5x. So why this is not acceptable is because when you find the derivative, you have to make sure that it's a derivative for every function. It cannot be a mixture. It cannot be a mixture. It cannot be this is a derivative, but this is not, and this is a derivative. It cannot be a mixture. It must be all derivatives. Right, so what is the correct way of doing it? Correct way of doing it is that before you find derivative of any function, just make sure you have simplified everything. Simplify everything. Okay, you cannot mix differentiated terms with non-differentiated terms. All right, so the correct way is to simplify all the terms first. So 2/3 x to the power 3 over 2, you don't have to do anything, just leave it alone. However, we need to rewrite this as 3x to the power half. All right, simplify everything first. Once you're happy already, okay, simplify everything means you express all the x to the power of something, so you can apply the power law. Remember, the power law is this: y is equals to x to the power n. So you must express all your x to the power of something, positive or negative index. Okay, so happy now already, right? Then you can apply the differentiation rule. Okay, and then simplify further. Right, and this convert it into positive index. That will be 1 over x to the power half, which is 3 over 2 square root x. Okay, so that's how we do it. So therefore, if you have forgotten all the rules of indices, please go and revise them. Look at the video that I've done earlier on. Right, so let's look at this question. We're going to simplify each term where appropriate. For example, -4, there's nothing to simplify. This one, you can write it as 1/4 x to the power 3. This one, we can write it as 4x to the power -3. So let's do that first. Okay, then let's differentiate. Okay, right, so this one, you apply the constant differentiation rule. You ignore the 4. We just differentiate this. So bring -3 to the front, and then -3 minus 1 gives you -4. Likewise, 1/4, leave it alone. 3, bring it to the front. So 3 minus 1 gives you 2. And of course, when you differentiate constant, you get 0. So let's simplify further. All right, and then this one we can convert it into positive index, which is -12 over x to the power 4. Okay, so that's the answer. Right, let's look at the next question. All right, simplify first. Okay, so now square root x is x to the power half. Right, so now we can differentiate. So you're given, remember the different notation that I mentioned earlier on. If you're given f of f bracket x, that means the derivative will be f prime x. You're finding f prime x. All right. So ignore your 2. 2 is a constant, ignore it, and then there's a power, bring it to the front. Power 2 minus 1 gives you x to the power 1. Likewise for the second term, and e is a constant. If you use a calculator, I think e is e to the power 1 is 2.718, so on and so on and so on. It's an irrational number. So you differentiate a constant, you get 0. That explains the 0 here. Okay, we simplify further. And then convert this into a positive index. Okay, this is what you get. All right, let's look at part D. All right, what do we do? Okay, yes, we're going to separate it into individual terms break up the single fractions into 1, 2, 3, 4 fractions. All right, I pull out the 1/3 first, pull out the 1/3 to make life easier, right? And then just break up whatever that's inside here into individual fractions. Okay, and then now you can simplify. 1/3 is a constant, so just leave the constant alone. So you just differentiate these individual terms. Okay, so differentiate x will gives you 1. Remember the earlier example that we have, derivative of 2x is 2, derivative of negative 4x is negative 4, right? And of course, negative 2 is a constant, so the gradient is 0. Okay, and then we rewrite it into a positive index. All right, so if you have forgotten how to know how to simplify this, I'll put the video link again, and then just click on it to revise all the rules of indices. Okay. Right, so having learned the concepts of differentiation, let's apply these concepts to problem solving. We have a diagram that shows the curved y equals to 6 minus 4x over 6 minus 4x over x, where x not equals to 0. I'd like you to think, why is it this condition is being imposed? All right, so we have a point 8 on the curve. Point A, it's given to be x coordinate to be 3, y coordinate to be negative 2. So what are we supposed to find? We're supposed to find the gradient of the curve at this point. Actually, what we are finding is the gradient of the tangent line at the point. Also, the gradients of the tangent line at the point where y equals to negative 10. And part 3 is to find the gradient of the tangent line at the point where the curve meets the x-axis. Right. So first part, let's try to find the gradient function. So in order to do that, we need to simplify our equations of the curve. Okay, so we can split it into 2 fractions. Now, I just want to remind you that we can only do that when you only have a term, one term at the denominator. Okay, where the numerator is heavier than the denominator, then you can split. All right, if we have things like x over 6 minus 4x, this is definitely not equals to x over 6 minus x over 4x. All right, please keep that in mind. Okay, so that's simplified it to get 6 over x minus 4x over x. Simplify further, will give you 6x to the power negative 1 minus 4. Right, so therefore we can go on to find the derivative, which is our dy dx. Okay, this one we're applying your constant law, where you just constant rule, where you just ignore the 6 and then you differentiate x to the power negative 1, bring the power negative 1 to the front. Right, there's no need to put a 1 there. Negative 1 means it's just negative. But if you want, you just put the 1 there, and then negative 1 minus 1 will give you negative 2. So this will give you negative 6 over x squared. And of course, if the derivative of a constant will be 0. Okay, so we're going to substitute x equals to 3 for part I. And so the gradient functions, the gradient of this tangent line, okay, at x equals to 3. This one will have gradient negative 2/3 x plus a constant c. All right, you can just substitute this point in here to find your c, but that's another story. All right, so what happened is when y is equals to negative 10, all right, so that will help us to find the values of x, find the x coordinate, because basically what we are substituting into a gradient function is we need the x coordinate, okay, because the gradient function is in terms of x. All right, so from there you can just do a cross multiply to get x equals to negative 1. Then substitute negative 1 into your gradient function, okay, which gives you the gradient at the point where y equals to negative 10 is negative 6. All right, so let's continue. All right, for part 3, when it says that the curve makes the x-axis is when y equals to 0, so we substitute y equals to 0 into your equations, equations of the curve to find your x coordinate. Right, so x equals to 3 over 2. So substitute x equals 3 over 2 into our gradient function, or your derivative, which is a dy dx. Right, what gives you negative 8 over 3.